Okay, hello.
Hello.
First point is choose the power supply. There's some echo.
Feedback coming from some. That's what? Okay, it's just. Do you have the speakers?
I have this microphone and my speakers. They're good.
Maybe I turn off my speakers. Whoa! And we should have a one-button operation for meetings. Huh? One-button solution.
Cisco.
Set up the meeting and.
Okay, it's ready. So the first point is choose the power supply.
Jonathan, can you say something? I want to see if we can hear you.
John?
Yes. Can you hear me?
Yes.
Good.
Okay, so what do we do for this power supply?
We have three choices. Two of which are pretty much the same, except one's a single channel, the other one's triple channel.
Did everyone see this email about the power supply?
They're all computer controlled. You can use LabVIEW to write programs for them. There's one that's like the Cadillac Geely of all the three, which is $800, and the other ones are cheaper. Well, you saw it in the email, all the information.
So what is the use of this power supply?
What?
What is the use?
Constriction? No. The other thing. Heat-shrink tubing.
Shrinking,
Shrink tubing.
epoxy, hearing.
And it's a USB control?
Yes. USB. And network. If it's the fancy one, it's the network and USB and everything else. Big colorful display.
Who's doing that noise? Okay. François, you correct? Who is the moderator here?
I trying to understand where the sound comes from.
What, shall I fix the sound?
We use this mic, so we don't need any other mic here.
Yeah, so do you have your mic on? Or no? You sure? Can you mute? My computer died.
Okay. Jonathan?
Yes?
Okay.
I mute whenever I don't talk.
So the price is
I think we can get that from the
You have to put the microphone behind the speakers.
the microphone.
Oh, your microphone.
Yeah, it's this one.
Snowball.
There goes TV.
What's the problem? Oh, maybe the guys pick up some sound?
Yeah.
It's not.
I don't know, maybe.
Hello? Ah, there you go.
Yes.
Okay.
Yeah.
The camera was picking up some. She was getting confused.
The camera doesn't work, but it's making problems.
Okay, yay. So now we have good sound. So let's talk. Tape sensor?
So we didn't decide for a power supply. We have three prices from 130 to
I
800.
say we choose the middle one.
The middle one, it is slow. That's the problem, but it's cheap.
Oh yeah, that's the problem, right? That's the defining characteristic.
But
We potentially can use the fancy one with an amplifier that we make for the piezo to do activation, muscle activation. And we can make whatever waveform we want.
for activating silent.
Yeah. So using the same circuit that Frederick is working on, which is my original piezo circuit, it would be perfect for muscle activation.
For muscle activation, Ivan, do you have enough voltage for muscle activation?
For the cardiac cells, yes, but for the
No, we're talking about this power supply here.
TV?
Yeah.
I said that plus an amplifier,
Okay, plus an ampere. Okay.
which is the
So
same
how
amount
much-
as the piezo.
how much is it gonna give altogether?
I think 3 amperes is very small. I mean, you can't even do shrinking or well, you can do shrinking, but you can't do any constriction with that.
With these two,
What would be the final voltage?
300.
300 volts.
If you connect an amplifier,
That's a lot.
but it's not the power.
Bro, I mean, for the cells, it doesn't matter. Like, as long as you have voltage in the bus.
Yeah, but you should check also the capabilities, what kind of waveforms it can give you.
Yeah.
And what is the response like? So we need your parameters.
Well, is it very different from the one that I sent you, John?
Yes.
Is it different from the grass?
Yes.
Yes, what?
Yes, it's different from the graph. Yes, it's very different from the one you sent me. It is a power supply that you can design the waveform. It has a 50 microsecond response time. So
50 microseconds.
maximum to minimum output takes 50 microseconds. The other ones, the lower price ones, maximum to minimum output can take as high as 100 milliseconds.
That's slow, 100 seconds.
50 per second is pretty fast.
Yeah, but 100 milliseconds is very slow.
Yeah.
So the two cheap ones do 100 milliseconds at worst, and the expensive one does 50 microseconds. The other nice thing about the expensive one, it can communicate directly with their same brand of oscilloscopes. So you can measure a waveform and then copy it and play it back with the power supply. They communicate directly.
Yeah. I don't see that we have a clear need for the expensive one.
I agree 100%. I don't think we should buy the expensive one yet.
Yeah. I don't see what it gives to have the one at 286 compared to the 134.
Because they're both slow, right?
Yes. One is channel.
The only thing that could be useful is it's a bipolar output plus 5 volts. So we can make the power supply for the new TIA, which is plus minus 15 maximum. Right now I only have one supply that's plus minus 11. This one is adjustable plus minus, plus the third channel that's fixed.
So maybe if you need for the electronic needs, for your needs in electronics, you know, $286, that's not too much, and we reserve it just for that purpose.
Because for the experiments with cells, like with muscle strips, this won't be enough.
Okay, so we go for the second one.
As you want, I can use the second one combined. I can use the first one combined with the one we have already to do bipolar output. It's not a huge need because I have to make a circuit anyways to power the new TIA once we get it working.
But they're not. You want to use typical supplies?
Can you repeat that?
You want to use typical supplies?
I can manage with that for now. It's not really a huge urgent need.
Because you might have to know it, right?
Yeah. Yeah, but whatever. I want Francois to get one for his oven. That we program the buttons and that's it, so we can make our transistors easier.
So then get the
Cheap one.
what? The chipper?
Yeah, just get the cheap one. It's okay.
EQ control. So you make temperature ramp.
Okay. Have you control?
Yeah. Well, yeah, it's serial control. So you just type. We can use the serial port output of LabVIEW to program it.
But it doesn't have any lab.
I'm not sure. I forgot. But it's just a serial output, so you can make the drivers easily.
Okay, so that's just based. Yes.
What?
This is text-based commands.
Correct. It also has programmable buttons. It has a button you can program on the front. I think you just press T1 and it's strict.
But it's not USB control.
It's not what?
Is it USB control?
Yes.
Serial port. Ah, that's the one.
And the serial port is for what?
Computer controlling it.
That's USB. USB is a serial port.
Okay. Okay, I think we go for the chip.
How many watts you have? Is it much higher than the one that
I don't think so. I have to check it out.
It's the same.
the same one? So you see, you can do construction. Only if you don't have one that do the other construction, no?
Well, constriction, is done with the fiber line splicers now.
The arc.
It will also be nice for the device that whatever his name is, Joel made, because we can just program a button, say click here, and now we can constrict the PLMA fibers.
Yeah, because the PID is the sensor is too big, so I can't put it in the oven. Either you put the fibers, either you put the sensor, temperature sensor, but you can't have the temperature sensor and the fibers in the oven.
And the PID needs a sensor.
Yes.
And there is no other way to have a
We'll work on that next week. Don't worry, we'll figure something out. But for now, we should get the power supply that we can then control.
I'm just thinking that we can this one has been but if we can get one more powerful, I think it's worth spending the money and getting one more powerful.
Plus, we will be able to use it to do experiments in the lab.
Yeah, exactly. So if it's powerful enough, you can even do, if it has 70 volts out, you can even do activation.
Okay.
It's very hard to find one that does high power with still having USB. Those are in the $1,000 range, like I sent in the previous email about power supplies.
Yeah. But Ivan was looking at the power supply from Grass, and it was what, Ivan? 3,000? 6,000?
Yeah, that one was old. It's $3,000, but you can do a whole bunch of different stuff, like different shapes of voltage, like pulses. The voltage is very high, but we may not need all of that.
I would get a good power supply. I don't know. My opinion.
Yeah, that it will cover our needs forever, like in terms of the biology.
Celui-là, combien?
Celui-là, il est 200. Celui-là qu'on voit ici, 135. 130 quelque chose.
Ok, 100.
Ah, 60.
Ça c'est if you buy a lot, maybe no.
Ah, ok, 134, bon.
Ok.
Okay.
Mais bien, il a pris
Yeah, for me the idea was to have a USB control one, so you can increase the temperature slowly without moving the knobs.
Yeah.
And you monitor the shrinkage, and once it's shrunk, you stop it. But
Honestly, I think we should buy both. We buy the cheap one, 135, and then we buy a more expensive one for the all the nice objectives we have: constriction, muscle activation, blah blah blah.
Yeah.
Il y a une communication à RS132. Il peut communiquer via le réseau, celui-là.
Il communique avec un câble USB.
Non, j'ai vu ici, il y a RS132. If you want to...
Ah, this is RS232. That's the old thing for computers, right?
Yeah, I have in the office an RS232 to USB converter.
Oh, okay. Okay.
They all use the USB driver serial port emulation anyway, so it's exactly the same.
Okay.
I can also use my make our own custom PID with that too. Very easy.
Yeah.
so we don't know too much about the software, but we guess it will be programmable to ramp temperature, the power.
If it's serial and it should come with a manual with some commands. Do you have a manual here?
Yes, I read all the commands already. It's very simple. It's just like set power 10, set current 5, and that's it.
Okay. And then you loop and you have a timer in the loop and we do it like that. Okay. Well, it's millisecond and what it takes for the computer to process that.
Mhm.
And remember, the number I quoted, 100 millisecond, is from full to minimum. So if we're doing a ramp, slowly ramping up, it could be a lot faster.
Okay. Okay. So it's not, okay. So you sure you don't need the 3-channel one?
I would like it, but whatever, it doesn't matter. I want Francois to get one immediately for his manufacturing of transistors.
Yeah, I think it helps because if
For sure.
the temperature rises constantly, then I can just monitor the shrinkage, and when it's shrunk visually, I stop it instead of turning the knobs and looking.
If we had the 3-channel version, we could have 2 ovens working simultaneously. If you want to have like 2 regions of heating at the same time, or I don't know what. Do you have a need for multiple control at once?
I would say maybe if you want to have a motor attached to one and to control, and then you can with the other one you control temperature.
That's pretty cool.
Or a piezo, but the piezo, it doesn't have voltage for the piezo. You need to, but you will still use it as a modulator for the piezo input, right? You can use the laptop for that.
Yeah, you can use anything for that.
Okay.
I would go for the simplest, because we don't know for future needs.
Having 3 channels, so you have plus, minus, and then they have a 5 volts.
Yeah, it's plus minus, then 0 to 2.5, 3.3, and 5. You have 3 choices.
Triple channel 2. Oh, these are the maximums.
I think so. Oh yeah, in the email, yeah, it's the maximum.
And this one is 30 volts, 5 amps. Oh, it's much more powerful than what we have. 30 volts, 5 amps.
Oh yeah?
Yeah. Ah, no, it's the same thing. Mais c'est un peu plus costaud. Parce que là, on va digitalement.
Ah, c'est générateur de tension courant maintenant.
Exactement, c'est ça.
D'accord, ok, c'est bien.
Can you program the current as well, or just?
Yes, 100%.
Okay, so you have 2 controls in current, right? All right.
So, cheap one or second one?
Second one.
Okay. Okay.
I think he's gonna use it.
Hooray! Next.
Yay. Okay, next is tape sensor. What needs to be done?
Okay, so Enrique is coming tomorrow.
Who? Enrique.
Enrique is coming tomorrow. Should we tell him to do?
Is it sure it's coming?
Yeah, he just called.
Okay.
He's gonna be here tomorrow. Tomorrow I go to Maxime, right?
Is
Was
it
it
tomorrow?
I didn't put it in the calendar. I have to write to hang.
Okay.
But I think it was tomorrow was the day to go to Maxime's.
Yes.
So it's good if you are here, no? Instead.
Yeah, it would be nice. He can all work either on the tape sensor or on the
Finger?
finger. Yeah. He wants to do connectorizing on the tape sensor, but I don't think he's skilled enough to do that.
Me neither.
So maybe we can put him on
Blue.
put him on finger. Now we have very small.
Put on blue. Glue.
PMMA. Should you work with the small PMMA fibers? Glue with PMMA, but because it's too small. So what should you work on?
Wednesday morning, you are at.
Wednesday morning, so it's normal, right?
Yes. Jonathan, do you think Enrique can work on the robot finger tomorrow?
Why don't you work on the glue?
Yeah, okay.
Tomorrow I'm going to work on the robot finger. I'm going to make some finger. Oh, I'm going to make the optics for it.
So epoxy. Okay, next topic is robot finger. So you work on it tomorrow, Jonathan?
Yes, I do. I'm going to work on electronic, and I guess I have to learn how to constrict them, or unless Enrique can constrict for me while I try and glue them on.
And is there anything more to add?
Nope.
Okay, so next is order from
What about Ivan's business?
Yeah, that's the next topic later down. TV?
Wait.
That's like 3 topics down is vision for Ivan.
So now is the score machine. Holes are too small, 0.5 and 0.25.
It's hard to do small holes like that.
I propose to make a sleeve adapter in the 1mm holes.
So we
just
need
order the 1mm hole scoring machine. It's $50 for both parts, top and bottom. And that's it.
the need adapters. Is it what you propose?
Yeah, make a sleeve.
But where do we find these adapters?
What adapter you use?
You have 1mm hole. You insert some adapters.
No, it's okay. I send it for 20. Or maybe.
The Chinese?
No, yes.
$70?
Yeah, because I remodeled it a lot smaller for smaller play. Very simple, nice, and I'll pay for it.
$70?
Oh, what do you mean? They can make the fiber. They can make small holes like that. Yeah, it's not going to be perfect, but the hole is going to be there. Maybe we're going to insert a wire inside to make it. You think so?
You guys really gonna use it? The grooving, are you talking about the grooving to it?
Yeah. Anyway, it's a good exercise to know what the limitations of technology.
Yeah, it's good to learn.
Just for like the real one, should we use the constriction?
I guess for plastic, it's easier to scratch or to.
We don't know that because we never tried with the constriction.
Because this way you can get exactly the proof that the spot you want. Like you know that every line is gonna be the same
um, the same distance between each groove, you know?
Well, if you make a device to make constrictions, then it will also.
Yeah, yeah.
It's just the issue of automation, you know, because now 3D makes it manually.
Guys, why don't we go with V grooves? Two V grooves in front of each other, very little space.
Because it's like, I mean, after I saw the constriction transducers, I honestly,
Me too.
I fell in love with this because it's invasive. You don't damage the surface. You don't.
Yeah, but you can't do that with plastic. Well,
you never tried. I thought that you were gonna try with the ones.
yeah, we have the device now. Yeah.
Yeah, but the best is to have a systematic study, and for that we need a machine. If the machine costs $70.
But it's not really a machine. It's just basically a blade positioner.
Yeah.
For the constriction, you can also make a machine that would constrict them hundreds in a row.
Right. But it's good to have the two technologies to compare and to push to the limit.
What's the limit there? Can they do the 0.5 millimeters?
Yeah, the limit is 0.016.
16 microns.
Okay, so then do it just for 1 millimeter and 0.5 millimeter. And I'm gonna find another solution for this 100.
It's set anyway. So if the small hole, the 250 microns hole.
Okay, we don't use it. Yeah, okay.
To just
Perfect. You're right. It doesn't cost anything. It's a free process.
So you deal with them, Dan?
Yeah. Are you gonna do it? Yeah.
So for the Chinese, I tell them no scoring machine.
Yes.
And the bath also, we're doing it no bath for the Chinese.
But when it becomes too thin, you simply cannot control it.
Just 1 second.
The depth of the grooving can basically break the.
Yeah.
With the constriction, it can go to a very small scale.
I know. I
For the back, do we also go with Pagnavi?
yeah, it's ordered.
Oh, yeah?
160 bucks.
Okay, so did you hear that, John?
Yeah.
Daniel ordered the bath already.
Did you change the channel?
Yeah.
Okay, very good.
Rest.
So Yassine's foulard?
Foulard?
Foulard bleu? Gris?
No, I don't know. It's written rest of the stuff is ready to be ordered. What is the rest of the stuff?
I missed. How about the prisms? I missed.
Oh, it's after. It's
The piezo holder, the frame, the breadboard, and that's it.
piezo holder, frame, and breadboard. Okay. Daniel, did you order these parts too?
Hmm?
Did you order the piezo holder, the frame, the breadboard?
Yeah, but the mounting frame, I think we ordered just one, right? The one we need that fills down.
In metal or
Huh?
plastic?
Yeah, metal.
Okay.
But the center adapters, they are cheap. They cost like 20 bucks because they are thin aluminum sheet and they are easy to machine. But I think we could order them just to have them on the road and to have them even Ivan expressed his interest because as long as paying 50 bucks for the shipping, you know, we include the 3 parts more for $60 more and it's okay.
But 50 bucks is for China?
Yeah, for the whole shipping, you know, instead of ordering later.
What's the name for these parts?
They're $100 each.
So they are not on the list.
I don't think
We removed them from the list.
Okay.
As I mentioned here for Daniel Fab Lab Link, we already discussed about, right?
So piezo holder frame and breadboard are ready to be ordered at Fab Lab Inc. or China?
China.
China.
Okay. Need to add adapters.
Hello?
Who can add these adapters on the list?
Which adapter? The eyepiece or the round Petri dish adapter?
The adapters for the
For the Petri dish, yeah.
Petri dish.
Yeah.
Yeah, that's an extra $100. Remember, we went over that with you, Francois, remember?
Oh, okay. Okay, whatever.
Guys, tell me if you're on the orders.
So I don't know. Are they already on the list or?
They were on the list. We removed them because we deemed them not necessary right now.
Who's gonna put them back on the list?
This is the consensus. We want to put them back on the list. Everybody agrees to put it back on the list?
Philippe needs Ivan said he would like to have them, and okay, let's ask Ivan because he's really into it. Because if you go and show this on the road, it adds something to the whole ensemble. Whatever.
What's the date we're going on the road?
What's the
Which day?
It will be a Tuesday.
We're going on the road on Tuesday?
Ivan.
Okay, thank you.
The Petri dish adapters are very important.
For now, no, but for example, right now I'm designing the bath for the CSA, okay, for the tissue scaffold. And I would like to stick to some standard size, if you know what I mean. So, the optimal size is the smallest size of a Petri dish. I spoke Daniel, which is 35 millimeters in depth. So if we use Daniel's stage for the micro positioners and everything, we can already we can already fit my future design for the CSA bath for tissue scaffolding.
Yeah, but so these round things that you call adapters, this can be ordered anytime. Because you have the hole, and these are things that fit into that hole, right?
Yeah, it's just the matter of like every time we have to pay for shipping.
Ah, okay, shipping. That's the
Yeah,
problem.
shipping.
Okay.
So we wanted to include them into the shipping, so we don't have to pay for the shipping another time.
But what if you're going to make shipping?
By the time we are ready to go on the road or go to space, I'll be in China. I can pick them up.
If you say it's fine. I mean, for now we don't need them because we use baths that are square. As fields. But the future bath that Daniel is ordering is already round and it's already designed for the Petri dish size.
Yes, and in the current order, those bath adapter is there. For the new bath that's coming, it's coming with a new frame and new breadboard.
Yeah. Okay. I know that Philippe. We had a discussion about the mounting around the microscope for the mosquito.
Mm-hmm.
Okay, and I know that they work with a lot with Petri dishes. Do they have a need for that?
Well, it's good to have the adapters for Petri dishes because if we go to the cell culturing and tissue constructs, like yesterday I downloaded a whole bunch of papers about the tissue constructs. And they all grow, the scaffolds all grow on the bottom of the Petri dish.
Okay.
So no matter what kind of experiments you do, like they always end up with a Petri dish.
And you took the measurements for the Petri dishes that Philippe has in his lab, the standard.
They have all different sizes. They start with like this bigger one and finishing with the smallest one.
because I know one concern was, okay, so this is the concern. It's not just our need. Because if you go there and put an adapter for the microscope on Philippe's microscope, the problem is compatibility with other students' work. And if there is no compatibility, every time we go there, we have to mount it, and every time we leave, we have to unmount it. So if you have something that fits both, then everybody works and there is no friction. Mm-hmm. So that is also value for us. So if they need the adapters, let's say we don't need them, but maybe Jonathan or the other guys need them.
Yes.
And since they have the mount on the microscope, it's there, nobody takes it out, and it fits for the,
Well, I would not count on them too much. I mean, it's not that I don't respect what they do, but or I don't care. But their experimental setups are so weird looking. I mean, they put a whole bunch of wires together. Every time it's something new. They change it slightly, so it's hard to say what they really need. So
maybe they forgot.
What's that?
Every time they forget what they did last week.
Well, what rather do is to make our stuff like something that does not it's not an obstacle for them. You know what I mean? So
that's what I'm trying to say, Ivan. Because so thinking the ecosystem terms, so it's a shared resource. Make interaction as smooth as possible, so everybody's happy. And even make it go there and always mount the thing,
Yeah.
Our mount stuff. Then we go there to work on our stuff, and they have something mounted. We have to unmount and mount our own.
Yeah, because
so let's order 2 sets.
Well, basically what I'm saying, why is it a problem to order the adapters now? It's so expensive?
No, you said the problem is shipping, so it's $100 more.
Okay, TB,
Yeah.
we should try and sell them the bath, and that's it. We'll sell them the Petri dish adapter.
To Philippe?
Yeah.
Yeah, I don't know.
But John, why too much more?
$100.
$100 to read the program. And if you order them, you bring them for free.
Yeah, but
Later on. So it's $100 for shipping.
no, it's $100 for the adapter. Shipping is $50. You say we order later, we have to pay $50.
So because we need later on. We get to order now. Maybe we will find them useful right now. We just don't know.
I think we should buy.
Yeah, printed or
Why
sealed?
don't you call? Do you have a 3D model? Why don't you send a picture to Jonathan and just ask them, guys, do you want this with that or without that?
I showed James. Did I?
And what did he say? Can you send him again? Have an email and if they say it's really important.
Well, the way they work
Then
now,
we
like the way they work now, they use Petri dishes, but they don't. It's not fixed in space.
Yes.
They just put it on top of the hole. And that's it. So they may not even need this because they also put that heating element on the bottom.
Yeah.
But for us, because if tomorrow we start working with cell cultures and we want to keep them on the bottom or on the scaffold, then we're going to be using different sizes of Petri dishes.
Understand. So
James, he wants me to design a frame for Petri dish with the breadboards to mount stuff, but that they can mount on their all the weird microscope, and that can go in the Z-axis.
Yes.
But that's what they did it themselves. Like last time I dismantled part. They put positioners together and they attached the
But I thought this is
microstation.
what we're doing. I mean, the deal was to have the stage that we are building that has the motion, right? Isn't that what you're doing?
I don't know why.
The idea was that the stage already is made like that, and the lens, they have a z-axis travel.
Yes, but the problem is that the travel is not enough.
But their stage is not for the stage they are using is not for that microscope, and it doesn't mount on.
That's why we wanted to build another one, right?
Yeah.
So we're not doing that. We're not.
Well, I didn't do because I assumed that the way that we made the experiments with the 3-layer bath, okay, we had good enough.
For us, yes.
Yeah, and if I make the mounting frame for the bath and the petri dish to reach that the same distance from the lens, we are okay, and the travel distance of the lens itself is enough.
Well,
I know that we are okay, Daniel, but
I never seen.
since the beginning there was a proposition, to make something that fits both needs.
Mm-hmm.
Well, we shouldn't really.
Because you machine something anyway, right?
No, they don't need the frame for that. They need a stage for that. So I should design a stage for them.
But it's on the field. It's on the field who needs the stage that would move.
Yeah, only they need
like
because
normal lens. It's the turret of the microscope turret is enough.
Because they use another stage than the microscope stage.
So
And they can use our stage. Can they use our stage?
The stage that they have over
The
there.
stage that we're talking about now.
No, the one.
But this is a mounting frame. I didn't design the stage.
Okay, it's a mounting frame, but can they use it?
Yeah.
Because they don't need motion and XY. They just need to be at the level of the.
Yeah, they can use it with the stage they have there that they put clothing on top there. I don't know. There must be. I can design a stage for that microscope precisely, but
Because the initial idea was to have something mounted on a Z stage, right? To have something mounted like these stages like here.
They want a microscope stage that goes in Z direction instead of just or
It's a waste of time and resources, in my opinion. It's only few who needs it.
Yeah.
Well,
but normally.
No, but
Yeah,
yeah,
because
that's
everybody
the thing, in my opinion, because in the beginning when I went there, before we went to the lab, I said, okay, let's arrange working space so we can share and there is minimum friction. And the only requirement was to have something that fits into that hole in the microscope and have it move in Z.
We can
Because their petri dish, they place it by hand, right? They don't need to...
like we did last time. They have a whole bunch of positioners. We can put them together and make it Z. Like for that.
That's what they did.
yeah. That's
actually.
We can do the same with Daniel's stage frame.
So anyway, so what I'm seeing is that I think there should be because Philippe is a very important collaborator.
Yeah.
So I think we should design for integration. You know what I'm saying? And everything we do in his lab, we have to be careful that it matches its needs. What is it?
It's the check. We received it today for the microscope.
Okay. So anyway, so let's just think in these terms. You know what I'm saying? Because it is an ecosystem, and I mean, if we just think about our needs, then.
Okay, so back to the issue with the petri dishes. I think that it's worth ordering them now.
Well, now I don't know anymore because if this thing, because my argument was if the petri dish is good for them, but then if the stage is not good for them, the petri dish mount is not good for them because they can't use the stage. So then you have to unmount and mount anyway. So petri dish, no petri dish is fine. You know what I'm saying?
I think we can make it with all those positioners that they have. We can screw it to the table and make it move up and down if they want to.
Can we, Daniel? Can you screw it on an XYZ?
Yeah.
Or
Because it has the mounting the
holes. Yeah.
the holes on the breadboards.
Hello, Vince. Vince is participating.
And the breadboard is standard.
Okay.
Hey.
Well, let's go like that. Also.
Hello.
Include it.
Hello.
Okay, so Ivan said include the petri.
The breadboard is standard.
Okay. Well, let's go like that.
Sorry? Sorry? Okay, so we order these adapters. Who can update the... Okay, so we order these adapters. Who can update the...
Vince, I think you're sending some echo. Vince, I think you're sending some echo.
I'm sorry?
There is some echo coming from somewhere. With a huge delay. There is some echo coming from somewhere.
Yeah.
With a huge delay. Hello, hello, hello. Go. Hello, hello, hello. Oh, I can still hear you.
François is the most clever guy in the...
Oh, I can still hear you.
François is the most clever guy in the...
Okay. So... Okay.
Okay, so who can... who has access to this? Who can... who has access to this?
That's why we need the purchasing system. That's why we need the purchasing system. People that are in charge of these lists, you can go in there and edit them live. You can go in there and edit.
Oh.
What do you use, Jonathan? A spreadsheet, or you just use, you have your list on your email that you bounce back and forth to China?
John?
Jonathan? Did we lose him? C'était toi, François?
No.
Hello? Houston?
Okay, anyway, I will send an email about this order.
Est-ce qu'on est en ligne ou c'est ton hangout qui a peut-être...
Non,
Ouais?
ça marche.
Puis les autres sont là?
Juste Jonathan.
Vince, il est parti.
Il est parti.
Ouais.
Peut-être qu'il y avait trop de problèmes techniques. Okay, now Aussie Optics. TB called them today. Spoke to Saidou, sent some pictures. He's going to come back with two solutions. LD with reduced resonance due to angled coupling.
Yeah, so he proposed, anyway, two solutions. One is to reduce Fabry-Perot at any connection. So he just uses fiber cut on an angle. And we can use that with the laser, okay? But still doesn't really solve the, well, he said that he can put the laser at an angle too, so he doesn't have light going back into the cavity, okay? So he said he can make us a prototype and test it and then optimize with them to see that we reduce the Fabry-Perot due to coupling in different places, and we can reduce the feedback into the laser, and that could be done by keeping the laser. LED, he said that the problem is a very low coupling rate. I told him that we need the numbers, how much power we have through the fiber, so we can decide for a photodiode with TIA with the proper amplification. Because these are fixed gains, and Jonathan and I ordered the smallest gain, and we can order the higher gain. And I told him that we need this LED one, because we have one sensor that already has a gap. So we can't take that gap out, you know. So. And he says that he's going to send us tomorrow.
Which gap?
The joint pack.
Okay.
He's going to send us tomorrow the cost. I expect it's going to be very expensive.
$1,000?
For both prototypes, maybe more. And I will propose them to become a member of Sensorica.
Yeah?
If the price is too high, what can you do? You just throw a proposition?
Yeah.
I don't know.
Okay, you will propose. Okay.
Yes. Well, if they come with like $5,000 or $10,000, you know, then you just do a proposition. You say, hey guys, you want to become partners? Okay, so that's about this. So it's. But already the guy gave me a lot of ideas, you know. So we might have Fabi Perot. We might have Fabi Perot everywhere on the fiber where you have two straight connectors meeting each other.
Sure.
Okay, and he says first you have one between the laser and your delivery fiber. As soon as you launch the laser in the delivery fiber, you have a cavity right there. Okay, then you have a cavity when you connect the connector, and for the joint touch adjustment, you have a cavity right in the gap.
Yes.
So we have a combination of three cavities.
Yes.
Okay, and that's why everything is unstable. Plus, we have some feedback into the laser, so we are in a worse condition. Okay, so he's trying to eliminate all the cavities, okay, with parallel ends, at least until you reach
The gap.
the gap. Okay, and he also tries to tilt the laser so the cavity of the laser becomes non-parallel to the beam. So if there is some light going into the cavity, that light is going to escape. It's not going to contribute to the amplification process, okay? So they seem to know these problems. They seem to have worked with other customers. And already talking with him, you know, I realized all these problems that we might have at the same time.
Yeah.
And I thought they're minimal, you know, but it turns out that they are they're sources of noise, which are important, because we're looking at very small intensity fluctuations.
Yes.
You know, I mean the mosquito demo, when you just show with the finger how it works, that's fine. The level of noise is very low, you know, but we didn't do any simulation or anything to know the level of noise and the level of signal, you know, to say that this is a good design or a bad design.
Yes.
It doesn't matter. Every connector that we have, it can be changed from ST to angled ST. Okay, so it's just there are ST connectors that are just cut in an angle.
Wow.
So they meet like this, you know, at an angle. So they cut each other in a 80.3 degree angle. So it's just a matter of connections, you know. Basically, think about it. So anyway, so he's going to send us these two designs. He asked me about volume. I said we're at prototype stage, and we're going to buy 2-3 at a time in case something burns or breaks. And
Okay, good.
he was interested in the type of applications. I told him medical robotics, and they're in Ottawa.
Yes.
Maybe next time Jonathan goes there, you can pay him a visit.
Okay, excellent. So we wait for this quote tomorrow. And yeah, we learned a lot because it's good. We have this feeling, but it's good to have confirmation.
Yeah.
Everywhere we can have Fabri Perot. Z optics, Prism search complete. Other optics to order.
Did we want to order anything else from them? From optics, like ball lenses, spherical lenses, something like that.
I would go for Peru because the lenses, you know, you need a design to know what lens to buy, and I have no idea what lens to buy. You need a design to know the focal length you need, you know, all these things. I might, well, there might be something for the, I don't know how we're going to connect the PMMA fiber, the 250 and 500. But we'll see. We don't even have connectors. That's why I'm trying to look for ferrules today. I was trying to look for ferrules online. 250, and they're hard to come by.
So we wait for this. We wait if you find some ferrules.
I don't think they have ferrules zeotics, do they? They might have. Let me check.
No, they're just just glass devices.
They have LEDs, beam expanders, windows, prisms, beam splitters, wave plates, filters, not enough.
Okay, so we order. That's it.
Yeah, I'll think about the PMMA fiber. I'll think about some solutions. I'm good for lots.
Problems using LED at 850. Jonathan?
It don't work.
So you discussed this problem with TB already?
Correct.
We don't know if it seems like the fiber is very strange, but it seems like the fiber is blocking the light. And if I look at the specs of the PMMA 300 of the glass fiber, so
Does this mean that you need special connectors?
it looks like the medium doesn't the medium doesn't support that light. It absorbs everything, which is hard to believe because I cut it short and.
Glass medium, you mean? Medium of the fiber.
Is it glass fiber or plastic fiber?
Glass.
Any ideas?
Doesn't make sense. Can you summarize the problem? Yesterday we could see that the PD was working.
So we have a 3.5 dB per kilometer loss.
But it's nothing.
What's the 3.5 dB? The logarithm scale, what's the percentage?
Yeah, and it's very low.
This is the absorption.
And for 850,
800 is here, 1000 is here. 850.
we saw that it's nothing. It's very small.
So then maybe it's launching. So this is an LED. Jonathan, this is an LED, right? It's not a laser, it's an LED, it's not a LED.
What?
The source that we tried at LED, right? It's not a LED.
That's correct. It's just an LED.
LED. So the LED doesn't have any focus the light. And it's already tiny connector, so you can't it's in there. Okay? And it turns out that it's unable to, or maybe it's the connector, maybe it's the coupling, you know. So the fiber is just brought very close to the emitting surface of the LED. There might be a window there. I don't know how close you get.
The fiber
You
is
can control that.
125 microns.
Fiber is 62 microns.
So it's a point that must catch light. Light goes like this, and you have a point where you want some light goes in.
Yes.
You have no optics.
There's absolutely no optics.
So you lose maybe 99% of the...
Hey, Jonathan, I think the LEDs, they always have a blind spot in the middle, right?
A blind spot? What do you mean?
Because you have the electrical connection right in the middle of the emitting diode.
Oh yeah, a few micrometers maybe.
So if we put that core of the fiber centered with the blind spot, maybe that's the problem. We're too centered on the dark spot.
Yeah, but it's designed for fiber launching.
But they are designed to launch in PMMA fiber, right?
No, it's glass fiber.
They are specifically designed for, they set it as compatible with 62.5, 125 micron glass fiber. and there is an SD connector. Apparently, if you just put the fiber in there, just put the connector in there, it should couple something. We know it works well. We know the front ends work well. When we put them in front of each other, they work. They see each other, no problem. And then we use the SD connector that you can, it's maybe usable. And I put the glass fiber in there, and either the fiber absorbs everything, or you have absolutely no coupling. It's really strange that there is no coupling whatsoever. Or maybe the fiber absorbs everything, which is a bit strange for me. I don't think the fiber doesn't absorb,
Not that much. It's a glass fiber. It's sold for that.
What is the property of the light? Like if you take a flashlight or light bulb, shine in the fiber, you'll still have something propagating inside, right?
You should get something, but there's something called an acceptance angle. So only light that is within that cone can propagate. Light that is outside of that cone will just it's deep.
It just doesn't get. Yeah. Okay.
But you should get something, at least some photos going in. Come on, it's unbelievable, Because what we did, we took a fiber connected to the laser, and we took another fiber connected to the detector. Straight line between them. You need at least something. You must have, Even propagating through the cladding somehow. You remember the white light? How it was, our hand was launching the light. Fiber was this small. You should have something even in the cladding propagating. I don't understand why people don't see it. Maybe we're too centered on that dark spot of the LED, because the LEDs always have. The LED is a diode, okay, and then you have the electrode that is soldered right on top in the middle of the plate, okay, and this is not emitting, and the plate is emitting. So if you look at the LED, you're always gonna have a dark spot in the middle, And I wonder if we're not putting the fiber right into that dark spot.
But they sell this. It's a product that's sold to the telecom industry. It's not like we're the first people to ever use that part. Doesn't make sense and it won't work.
I know. I gotta play with it a little more because I think maybe if we vary the distance between the LED and the fiber, if we don't get enough close, maybe we can get some light.
Well, at some point your fiber will start catching photons from the room.
Yeah, you can always propagate light, I mean, come on. We just take a pocket laser and we roughly put it on the fiber, and you can see it shining on the other side, right? So it's not that critical. If you do it with the laser pointer, something should get inside,
Well, I'm just thinking that if you go like too far from the
yeah, you're gonna see less and less,
Yeah, well, if you go far from the LED, at some point you will start catching photons from the room, and that might seem.
Okay, that bounce around even from the.
Yeah, well, just like Jonathan, he was turning it towards the window, and he saw the signal. So that may look like the signal from the LED, but actually it's not, unless you move it around.
No, because whenever we place the fiber somewhere, we just flip the laser on and off.
Okay.
Flip the laser on and off, and we follow that signal,
So when you put the laser in the LED in front of the PD without any connection, you see.
They see each other, no problem.
Yeah. So.
Okay. So
it doesn't fade. It's not the fact that the PD sees light and then needs reactivation.
No.
Okay. So it is a fiber. If you put them together, they see each other.
Everything works individually. They just don't couple.
They don't couple to the fiber.
Your fiber is broken.
Maybe the fiber is damaged.
I just got it fresh and I don't know why it's so critical. Come on, you just get any light. Grab even a. Hey, I coupled an LED red into the glass fiber, which just that I could see it with my eyes. The intensity was small, but I could still see it with my eyes on the other side, you know?
But if you take the fiber that you use and shine the laser inside, the pocket laser.
Yeah, for sure you're gonna see something like that. Anyway, continue. I will explore.
Let's brainstorm this.
Laser drivers still not tested. What does it mean?
I didn't test them yet. I hope they work, but I have high hopes. It's a nice German chip, but I haven't had no time yet to do it.
Okay, the one chip solution.
Yes.
Micro manipulators.
Jonathan, where did you put the fiber with the connector? Did you place it somewhere?
I put it with all the transducers.
Perfect.
So here, Frédéric worked on it yesterday.
Yay, Frederic is working on it.
The micromanipulator.
This I'm talking about the Scientifica tool, not the piezo.
All right.
All right.
Okay. Yeah. Okay. So Ivan showed me an update yesterday. So the best deal Ivan was Taiwanese one.
It's not bad. So Betty Zhu, Jonathan, just to let you know that Betty Zhu finally replied. So her price is in the range of the time and position.
Zhu replied?
No, it's
right.
different tool. Yeah.
I said different. It's another spying us for another project.
Yeah. So I think that like last time when we worked at Phil's, I kind of confirmed it for myself.
Hello.
Hey, hello, Bob.
Oh, Bob is spying on us.
Yeah.
Look, Francois. This is a little
Yeah.
Yeah, it's a proof of concept.
Yeah. I just got here late. Seeing what's happening. Don't have just.
That's okay. It's mostly about buying.
So I confirmed it to myself that we don't need micrometers for the rough positioning. One of the micrometers may be how to say useless, not useless, but also like harmful because they reduce the speed of the experiment.
You don't want to buy micrometers?
Well, the positioners without micrometers, the ruler on the rough position.
Oh, you don't need the ruler.
I need there is a ruler.
Yeah.
But I don't need micrometers.
Okay, you just need a position. You don't need to know.
Exactly. Yeah.
Yes, because your eye is the feedback.
Yeah.
Okay. Perfect. Yeah. You don't, so it's a closed loop system.
Yeah.
That is integrated with your body.
Exactly.
Yeah.
And basically, I will try to talk more about like maybe I can reduce the price still, but the price initial price was 500 for 2 pieces. If you want to buy more, we can order from the Devon Young, another Chinese guy. They sell all types of micro positioners with micrometers, translation stages for very small prices. Like I asked him a question about 7 pieces, and he thought that I was going to buy all these 7 pieces. So for 7 pieces of different travel range, it was $400. For 7 pieces of different single axis translation stages. Like how much did you pay for this one from Forlands?
These are like 400 each.
Yeah, so we can buy 7 of them for 400.
Yeah, perfect.
So I can give you, Francois, so I will email those guys and ask them to generate the quote from Thailand. And,
yeah, get a box full.
Okay.
Yeah, I'm here. It's all right.
Jonathan, I took an LED. You know, my little laser pocket has a laser red and an LED white.
Yep.
And I just put the fiber close to it, and it glows on the other side.
Okay. So something strange.
There might also be a problem with the photodiode here. Maybe the light that comes out of the tip of the fiber is too small as a point source.
Yeah, so our PD is not optimal for that. The problem is I had the same problem with the mated pair of our LED. Remember we bought one of each? The transmitter and the receiver, and even the receiver doesn't see it through the fiber.
Can you repeat?
Yes, the LED source that I'm using, I bought from the same company, its partner, the LED source's photodiode. So I still couldn't couple between the two, even with the photodiode that the same company sells.
Okay.
In DigiKey?
Yes.
No, that's from me. Is
So
that
the 850 LED and 850 PD from DigiKey, both from the same company, they don't talk to each other.
okay?
Not through the fiber. By themselves, with no fiber, they communicate fine.
Wow.
So maybe the center is blind.
Yeah, then maybe there's another line. Yeah, the problem is launching. It's not the fiber. The problem is launching.
So,
Coupling.
what would be the solution? Like, can you,
Okay, yes.
using micropositioners, can you write the distance and see if there's some response?
Mm-hmm. Yeah, I can put some lens. I can use some lenses to try to.
But
I can drop a lens in there.
generally speaking, it's the problem of connection, basically, right?
Yeah.
So,
I think so.
if there was a connector that would be optimal for these two devices, it would make it work, right? You think?
Maybe, yeah. We need a lens in there. We need to put a lens in there. Maybe.
Because obviously, you guys proved that if they see each other, but they don't see each other through the fiber, which means that the problem is with the sending light in the fiber.
Hey, what if I make the fiber like a ball? Like a huge ball, tip of the fiber.
You will catch more light. But is this light converged to the fiber?
Sure.
Should.
But you now play with the plastic fiber, right?
Glass.
Glass. But then you will need a plastic one for the ball.
No, you can melt.
Oh, you melt the glass.
melt the
right.
glass.
Yeah, you do that.
I can try that.
But we saw that a very big lens is like no lens. Why did we see that?
Because the wall becomes flat, right?
Yeah, right.
So you make a small ball.
And in this case, it should work. Because you want to catch bigger surface of light.
The problem is that you can't drop a lens in there in the connector because the connector won't connect anymore. Because you add some distance, right? You know how you connect? You push and then you screw.
So why is it sold like this if you can't use a lens?
I don't know. Anyway, we'll try different things. Okay, this is not very important because it's 850. This is to explore the other wavelength, right?
Okay.
But we still have 1550. It doesn't hold us back from the mosquito.
No, the reason we used 850 was because the PD came with a TIA
Yeah.
and was very exciting about that.
Yeah.
So we have to now try 850 laser.
Well,
We'll have our Fabry Perot problems, but we'll have a TIA integrated PD.
That's a good idea. So we should buy an 850 laser, yeah.
Yes, we order from DigiKey next order.
Huh?
but the laser, I thought that the laser concept doesn't work anymore because it gives us a very big fluctuation of the signal.
Yeah, it depends. So if you... It does, but Aussie Optics seem to think that they can take that away by aligning and rearranging it.
Because LED, well, as far as I understood that, it's a simple way to, well, first of all, simplify the technology. And so basically you replace the laser with the light source.
Yeah.
Yes.
And which means it also makes it cheaper, right?
It does, but it makes it. You see, you have coupling problems.
Yeah, but it's the matter of finding the optimal connector.
You know, the guy told me from Aussie Optics today. He said that he can't do better than something between 100 microns and 150 microns spot size when he focuses the light. No matter how sophisticated optics you use, you know, like three parts optics that correct for spherical aberration and everything you want.
Yeah.
They can't get lower than 100 micron in diameter. And we want to launch it into a fiber that has 62.5. Okay.
Yes. So
you lose a lot of, you lose half of the light. You know,
So LED has
you lose like 50% of coupling.
It has limitation.
Yes. Because it's a very broad surface that emits, and it's non-coherent. These two things. Okay.
it's like a fireplace compared to a point source.
Yeah. So
Okay.
you got,
So next topics are about the engaged grants that we should abuse.
Yay!
So we almost have one with Laval. Can we check the NDA?
okay.
I-
Yeah, I
is
didn't
it-
have time to check.
yeah, it's quite short. So
Okay. Yeah, I saw you underline some important things.
yeah, because it's
The only thing I care is for them not to restrict us to do anything we want with what we develop with them.
so they won't restrict us,
Yeah.
except if we use some knowledge they
Already
had
had.
already.
Okay. Yeah, that's fine. So then it's fine for me.
Perfect. So I think we can sign and send it.
Yeah.
It's the only point that we should be aware, because
Yes.
they can sue us if they see that we publicize some of their
Okay.
stuff.
Okay.
But they don't care if we make our stuff public.
Okay.
Engage any other ideas. Would be nice to meet some people doing some OMEMs, to have this Fabry-Perot cantilever. So you have a cantilever with optical guide and a cavity. So so it's a cantilever, but
I tried that at Dilson. I tried to take one of these cantilevers and attach it to the fiber, and I had some assembly problems because the cantilevers he buys are coated with gold or platinum, so they're mirrors. You know, and I try to put the fiber to them. You know.
yeah. So you have the cantilever.
Yeah,
is
but
like this.
Ivan just rejected that idea because he said coming back to the fucking cantilever, and he didn't like, because don't forget that now the light propagates outside.
No. The idea is to have the light coming from the optic fiber, and here you have your cavity.
Oh, with the joint.
No, ma'am. So it's this is solid but transparent, and you have mirror and mirror, and you already have a mirror here.
Okay, so what you call cantilever is like a small lever.
Yes.
Okay.
So this guy moves, and here you may have a Fabry-Perot,
Okay.
and maybe it's just some glue here, or something that is gravé.
Yeah, we know the problem with the glue. It's the problem with the glue is that it's not stable in time. But okay, I understand what you mean. Okay.
Yeah, just as a proof of concept, the glue.
Okay, it's
Or a shrinking tube.
it's a very complex assemblage that we can spend so much time working on that.
No, but I will explain you. It's a no-mem. You will, comment tu dis graver?
Etch.
Etch. So this is your. This is the cantilever. This is the optical guide. This is the resonance cavity, and here you make it compliant. So you track it, so it can. Here it's a point and it moves.
Yeah, but then you have okay, I understand.
But how gonna make
It's like a hinge.
Hinges.
Hinges.
The size of Dilson's cantilever is only 50 microns.
Yeah, I know. So usually it's 450 microns. But this by OMAMs, it's doable. They do that politically. They know how to coat a mirror here or a semi-transparent mirror and a mirror here.
But what do we really gain making this like sensitivity?
I would like just to know if it can be as sensitive as an AFM, but with light never going out of it.
Well, it does, because here you have a cavity, right?
Yeah, but
It's just it's basically
it's not like this.
It's redesigning the fiber. You just made the fiber grooved fiber but square in the cross section area.
Yeah, or you can have it round. Exactly, it's the fabric perro but miniaturized.
But to me, it looks like grooved fiber, like the whole concept.
Yes, except that you have this resonance here that makes the sensitivity go 1,000 times, maybe.
Yeah.
Well, we can try. I'm just thinking that right now our problem is not sensitivity, but the signal to noise and
Right.
the signal instability.
I know, it's another project. It's totally...
That's like a new engagement, new project, Mosquito 5.
Yeah, these engagements are good for exploring this
Yes.
concept.
For example, for the space agency, we need to come up with something, preferably tested before the beginning of summer. So we need to optimize our resources and concentrate on one technology that would be doable in our lab here. So I see the constriction fiber as the best because it's very easy to calibrate.
Yeah.
So if we optimize the constriction procedure, we can definitely try to work with tissue scaffolds. So it's just the being, how to say, targeting on the CSA. Further on, yeah, we can do explore other.
But you can do an engage with a CGEP that is able to make a device for automated construction.
Yeah, for sure. I offered them to work on this because when TV knows exactly the parameters of the construction, remember I sent an email to everybody with the different situations. It's like the number of constricted, those weights, then the size of each one, the length. So it's like this small or this big, and also the depth. It's like this small, this big.
So there's a systematic study to be done here.
Yeah. So if we optimize this, and I think that optimal solution will increase the sensitivity also, and then we'll have an idea on how to make this for different diameters of fibers.
So how do you see this this experiment, this optimization?
Well, scientific model. TV doesn't matter.
Okay.
You can have a basic model and then try to vary it and fit the parameters, see if it fits roughly the model, and then you can migrate.
Because just by I don't know, by luck and by TV's experience, he already made one that is as sensitive as the joint. We tried it at Phil's last time, and
it's very sensitive.
Yeah, if we had electronics working, we could make a very good experiment.
But we have to push to the limit. So do we do it ourselves, or do we transfer this project to?
We can do it ourselves. We can do ourselves whatever we want if we have some revenue.
Yeah.
Once you have some revenue, you can have some loose time to do. Because I would like to work on something like that.
But if we,
why give it to someone else? Why give my pleasure to someone else?
I know. If we do that with a tech, they can help a lot. And you can still work on it.
Yeah, but I understand. There is room for passion. It's just we have to generate some income first. So.
Well, TV, say, for example, if you do it manually, you said that once you remember, when you're doing transistors here, you said that you can make like 5-6 transistors a day easily.
Oh, 20.
20, okay. So 20 is statistically speaking, like you vary different parameters and you kind of have a feeling of the optimal ones, right? So if you make 20 transistors per day, playing with glass fiber, probably in couple of weeks, you
Oh, okay,
you will
make
know.
different sizes. Yeah, for
You
that
will-
we need
you will
the
know.
Systematics to do.
yeah, but for that you need the piezo to pull and to know the parameters. You need something to pull. You know. I mean, you can't pull it by hand because you cannot do
Yeah, it's too much.
20 different types
Yeah.
because you can't control these parameters. You know. But if you have like a small stepper motor and if you have a controlled power supply, you know, then you can do 10 different ones, but you know exactly what's the difference. Otherwise, you can't control it. You're gonna do 20 different ones, but
you won't be able to.
because
group them.
because if you have 4 constrictions, you want to do these 4 constrictions the same, maybe. Okay. And how can you do 4 constrictions the same by hand? You can't.
Yeah.
You will have variability inside the same transducer.
So the power supply that you want to order, is it good for?
No.
No, it's not enough.
It's a matter of the piezo to hook it up to the.
So we are back to the first. We need a device for systematic study of this construction.
Yeah.
And
Another point,
yeah.
how long do we wait with unstable electronics until we do an Optech grant to try and get them to make stable electronics?
Yeah, so that's the also the point here. Where is it? Optech engage. We can ask them to do the mosquito with LED, but there will be a delay.
Yeah, I think we have so much to try, so much on the table. Let's at least wait this cycle of trial, and maybe when we have it in our hands, and we don't know.
If we are really stuck, we will.
Yes.
Well, would you like to concentrate on this, like optimizing the construction part? Say you make this your project for the next 2 weeks, you know, and in 2 weeks from now, you say, okay, these are the results. But you said you need piezo.
I can optimize, yeah.
You need piezo for that.
Yes. You need
Yeah,
to-
but for Philippe, it doesn't need to be optimized.
No, I'm talking.
I'll make
about-
20, and one of them is going to be the best one, and we're going to choose that one.
Well, okay, so I'm talking about the device to make it, you know, like an industrial.
Yeah, I need a piezo for that. I need a piezo.
How about you try the plastic ones to constrict?
Yeah, that we can do as soon as we have the power supply. We can constrict as soon as we get the power supply here, the device is there.
So let's do that because I think that for the space agency, the plastic one would be better. It's more reliable, less fragile.
I don't think we have enough resolution for a space agency. You think so?
I don't know because we don't know the size of the scaffold. Like yesterday, I read those papers, and there's so many different types.
Oh, you're talking about the other project. I thought you were mentioning sensor.
No, I'm talking about the one that we submitted.
Yeah, okay.
So maybe 250 micron size constrictor made of plastic will be good enough to make this. So this is the tissue scaffold.
Yeah.
Yeah, about the tape sensor. So tomorrow it doesn't work because you're not here.
Okay.
When you think you can work on it?
Thursday, Friday. So the following is connection and optimization. And I don't know what you want to do more with it. You know?
Just mount it on
Package it and have it like a demo. Package and have it like a demo. Does that work? Okay.
But it works the way it is.
Yeah, I just need to pull the fiber a little more inside.
Can be presented to the Zoom.
Yeah.
So how about you try, like when we receive the power supply, you try the constriction transducer made of plastic.
We can already constrict with the power supply we have, the plastic.
Why do you need power supply to constrict plastic?
No, it's just to have to do when we shrink or when we do the epoxy curing, we want a constant temperature. So we want to just set the computer and it doesn't move.
But to try, you can do it manually to see.
Oh yeah, sure. The only problem, I don't have connectors for this fiber, so I can connect it to the Swiss fiber. Because I don't have a ferrule that has a hole in the middle of 150 microns or 500.
So if you get a fiber but you don't have connectors?
The company doesn't sell it with connectors. There's absolutely no connectors for this fiber. So, but I have some ideas to make one.
But if there is a fiber, there must be a connector.
Which one?
Maybe not forest.
But still, like, they are used for telecommunications.
Yes.
So they do connect it somehow.
Yeah, I guess.
Plastic.
But maybe it's not the ST7, maybe.
Yeah, no, we took here. Look up. Yeah, we took off here. That was not the race from last week.
Maybe you can make it with plastic stuff.
Why do we use these fibers?
Exactly the same document.
To prove the concept, even the constriction works for both glass and plastic. Because if it works for plastic, it's an invasive method for subsidization. It's like it does not break the structure. Like you can't use grooving for glass, obviously, right? Because it will break it. But maybe you don't have to use it for plastic either. You can do constriction for everything.
Yes.
And then we are set with the technology. We just optimize it, find the perfect conditions, and make the device for automatic constriction. And we are done for the rest of our lives. So we just vary the lengths, the diameters, and I check the state. I calibrate.
Yeah.
So I suggest to focus on this.
Anything else?
Yeah, there was another point. No?
It was CMEC next step. Jonathan, any word on CMEC?
Do we wait for Frederick to continue his work?
He said he will have an answer April 7, but did you talk to him about CMEC?
A little bit, not really. We looked over the document they sent us from CMAX, and that's about it. Comprende?
Yes.
Well, but Frederick is going to work on this project anyway.
Yes, so do we launch the grant with CMEC?
Or do we save CMAC for something else? Because if I work with Frederick, he'll keep me sane enough to follow through on this piezo. But I want mosquito electronics stable before I go back to piezo fucking shit.
Yeah, I mean, if Frederick likes to work on this, you know, it's the only project that he's kind of.
And CMEC cost 2,500.
Well, 1,000 for it. You might.
If we can sell one piezo, it pays for itself.
Yeah, exactly.
Sure, but if Frederick works on it, is it worth it?
Yes, maybe.
Yeah?
Well, we should have a meeting with Frederick and discuss that.
Yeah?
Right. Yeah.
Okay, Bob, you want to talk about the value accounting system?
Beg pardon?
You wanna talk about the value accounting system?
I wasn't.
You wanna give us some feedback?
It's very difficult for me to hear in these meetings to understand what people are saying. Okay. I guess I would. Yes, I want feedback, but I want feedback that I can understand, so that email or something like that is much better.
Okay, so let me just say this. So Bob, yesterday we had a meeting, and he actually showed me how you can log past time and past prototypes and past designs. So last time I was with you, we tried something and it bugged. and that was because you had to put the date first. Anyway, so now Bob made it probably much easier because it's kind of non-intuitive to know that you have to put a date in order to unblock all the other, the pad and the input button and output button. So basically, the form was blocked because it needed the date. Okay, but now
I fixed.
You fixed that. I
fixed. Oh, I'm sorry. I fixed the form so that it will now tell you that you have to put a date in there, and I fixed it so the buttons. I thought I had disabled the buttons, but it was like bad programmer. They look disabled, but they weren't. Now they are disabled. So yes, you have to put a date in, but it will tell you that.
Okay, and I think we still have a problem with time symmetry, right? If you log, is that solved, Bob? Let's say you log a resource and then you forgot to log its predecessor and link them together. Can you do that now? Because it's easier to log the predecessor and then log the things that you built on top, and you continue linking these things together and making the connections. So have the previous stuff before and add the stuff that came after and link it. And the idea with Bob was to have this symmetrical in time, so you can start at any level and build upwards or downwards. Okay, so you can input predecessors and you can input stuff that you did after, right? Is that done?
No, I have some information from Daniel about, and we're having a conversation to get some examples that I can work with.
Okay.
I will. I'll be happy to have any other examples also, existing predecessors that should be linked together.
Okay.
And then I'm going to experiment with some ways to link them together, and we'll put something out there. It's my highest priority at the moment. I need the examples to work from. And so I'll be happy to get anything I can get.
Okay, so Daniel, we can go through this process of logging past time and past designs, okay, and linking them properly. And the ones that are not linked, Bob is going to link them in the background. You just send him a list and tell him this one should be linked to that one because this is a predecessor of this one, okay? So you just need that list and what are the relationships between things, okay?
So I sent him the links to the past models, and I showed him where he could check to have an idea about the timeline of the models.
Okay.
But I didn't have time before to send to make a list of parent and child designs.
Okay. Okay. So. Because many of you guys are not at these meetings, and we also discussed an issue about. No, Bob, I'm not going to talk about ontology today. So, Luther, Daniel. So another idea was that we need to be able to see. For example, you want to see your designs, right? Mm-hmm. And you want to see them in a layout, so let's say like a network or a tree. Okay, so you want to see your designs just to see if you forgot anything, if everything is connected properly together. Mm-hmm. Okay, so that was another thing that I proposed to Bob. If he's whenever he has time, I don't know where that priority is for his work, but the idea is to have an easier way to find yourself within your own work. Mm-hmm. Okay, to be able to look at a page and see, okay, these are all my designs, and I can see that they're properly linked together. And oh shit, I forgot there's a hole there. I forgot there's something missing. Yeah. So you can spot it right away without going through the list mm-hmm. and building individually and building this structure in your head. Mm-hmm. You see, so that's a sort of an user interface kind of thing that mm-hmm. we need to look at.
Yeah, this is good.
Yeah. Mm-hmm. Okay. So this is what we discussed during the meeting. We also spoke about some other deeper issues about the system. You know, we're not going to get into it now. So.
I like the idea of being able to see your own work very much. I would like to have a little bit more conversation about how you want to see your own work. Yeah, you know what is the presentation, but that will be really easy to do.
Bob, I think we lost here in the transition. We used to have in spreadsheets, any member could have, you know, the alert, you know, on the, how do you say that, a notification. Anybody could subscribe to changes into the time spreadsheet, and whenever anybody logs time, you know, you receive an email and you can go check. Well, that peer review was lost in translation. So we can't, you know, it's not just for checking others, but sometimes it's also to see what is getting done and what is not getting done.
Exactly.
You see? So you have an idea, oh, okay, that person worked on this today, so, you know? So for somebody that's doing project management, you know, it's important to how things are evolving, you see?
Yep. Yeah, I have notifications on my to-do list. We'll see where they, you know, I'll put that out on the GitHub issues list too, so we can prioritize it.
But you know what? Even if there's no notification, if I decide to go there and just have a look at what everybody is logging,
without editing,
without any editing or any notification, you know, it's at the beginning it's just giving access maybe.
Yeah. Yeah, that would be easy to do now. What I've got out there now is you can see your own contributions.
Exactly.
Yes. Yeah. So definitely can put something out there for all contributions.
Okay. That's why, you know, he wants to check how projects are going. He just by himself he goes to the page and he just looks at what kind of projects were logged and how many hours and a short description of activities.
Yep. Got it.
The way I would like to see contributions is much like in folders, like project folders and then subfolders with.
You don't see them like a network that you can navigate,
or like a tree. But I think that what is already on every computer and what people are used to. It's already, you know, the way Windows presents the interface, it's already optimized, and I think it's already there. There's been a lot of studies on this, and they came to this conclusion for a reason, you know. So I think we can stick with this
folder structure, tree structure. It's a tree structure.
Tree structure.
I heard some of understood some of that. Could you write it down either in the group chat or send me an email with it, please?
Okay, there is something about when I was
or you can put it in the meeting pad one way or another. That would all be
okay.
Because
there was another thing, Bob. When I was logging things with Daniel, you know, that for some work, Jonathan was also it was a code development process. Okay, it was a code design process. Jonathan started it. Daniel, you know, continued it. You can't call that two versions. They were working on the same file. In other projects for 3D design, you know, Ivan collaborated with, and for now you can only have attributions to one person. What we did.
Yeah, I'm missing the problem here. Can you? I don't know how to get this to so that I can understand the words that people are saying. It's very fuzzy and.
The problem is the attribution resource that was made, and sometimes that resource was made in collaboration. So you have we need attribution for more than one members. So let's say Daniel and Ivan produce the 3D model. Okay. For now, you can only select one author.
Okay, understood. Understood. Yes, we need authors. All right.
So to select like and Daniel, the way we got around that, we put the one that we thought was the main designer, and we put the name of the other one in the description.
Yeah, we can add multiple authors.
Okay. That's my feedback for now.
Yeah, I'm interested in the details of somebody was describing the way that they wanted to be able to see something, and they had a very specific idea of what that was. It would be really useful to have that written to me in an email, and I will pay strict attention.
Yeah, that was Daniel gonna do it.
Okay, I apologize for my bad ears or the bad connection or whatever, but
no problem.
I'm happy to be in the meeting anyway, just to get the sense of things. Right?
Thank you.
Okay.
Was that all?
Yeah.
Okay. Thank you.
Okay.
Thank you, Bob. Good luck.
Bye then.